Imagine you are trading snacks with a friend. You do not remember how many you started with, but you know you gave away 3, and now you are holding 5. Almost instantly, your brain fills in the missing number. You started with 8. You just did algebra. No letters, no symbols, no equation on a board. Just your mind quietly working out a number it could not see directly. That is the part nobody tells you. Algebra is not a strange new kind of math that arrived to ruin your afternoon. It is something your brain already does. All algebra adds is a clean, reliable way to find a missing number when the problem gets too big to solve in your head. And most people do not actually hate algebra. They hate the moment a letter appeared on the board and nobody said what it was for. I am Daniel, and this is Simplex Academy, where we take ideas that usually feel impossible and make them simple from the ground up. So let us rebuild algebra from zero, in the order it should have been taught the first time. Let us start with the big picture. In arithmetic, you already know all the numbers, and you just carry out the operation. 3 plus 4 equals 7. Everything is out in the open. Algebra is what you use when one of the numbers is hidden, and your job is to find it. That is really the whole subject. Algebra is the math of finding the missing piece. So why the letters? Here is the honest reason. When a number is unknown, we still need a way to write about it and work with it before we know its value. So we give it a temporary name. That is all a letter is in algebra. It is a placeholder standing in for a number we have not figured out yet. People usually use X, but there is nothing magic about X. It is just a common choice. You could use any letter you like. The letter is not a mystery. It is a name we are holding for a number until we can pin it down. A letter like this has a proper term. It is called a variable because the value it stands for can vary or is simply unknown for now. Think of it like a seat saved with your name on it at a busy table. The seat is real. Someone will sit in it. You just do not know exactly which chair it is yet. The variable works the same way. It points to a real number. We are just waiting to discover which one. Now, before we solve anything, we need to tell apart 2 things that look similar but are not the same: an expression and an equation. An expression is just a piece of math with no equals sign, something like x plus 5. It represents a value, but it does not make any claim. It is like a phrase, not a full sentence. An equation is different. An equation has an equal sign, and it makes a statement. It says the thing on the left and the thing on the right are the same amount. So x plus 5 equals 12 is an equation. It is a complete sentence that claims 2 things are equal, and that claim is exactly what lets us solve for the missing number. This brings us to the most important idea in all of algebra, and it is the one most people were never told clearly: what the equal sign actually means. Most of us learned it as a button that produces an answer. You see 2 plus 2, then the equal sign, then out comes 4. But in algebra, the equal sign is not an arrow pointing to an answer. It is a statement of balance. It says both sides weigh exactly the same. So here is the mental model we are going to carry through this entire video. Picture an old balance scale, the kind with 2 pans, one on the left and one on the right. An equation is a scale that is perfectly balanced. Whatever sits on the left pan weighs the same as whatever sits on the right pan. The variable is just one of the objects on the scale whose weight we are trying to discover. And solving the equation means carefully rearranging the scale until the variable is sitting alone on one side, because once it is alone, the other side simply tells you its weight. There is one rule that keeps the scale honest, and it is the heart of everything. Whatever you do to one side, you must do the exact same thing to the other side. If you take 3 off the left pan, you have to take 3 off the right pan, or the scale tips and the balance is ruined. That single rule, do the same thing to both sides, is the engine that solves every equation you will ever meet. It is not a trick to memorize. It is just keeping the scale level. Let us watch it work on the simplest case, a one-step equation. Say we have x plus 4 equals 11. In words, some number plus 4 gives 11. We want x by itself. Right now there is a plus 4 sitting next to it, cluttering up the pan. So we remove it by doing the opposite. We subtract 4. But remember the rule. If we subtract 4 from the left, we must subtract 4 from the right too. On the left, x plus 4 minus 4 leaves just x. On the right, 11 minus 4 gives 7. So x equals 7. And here is the habit that will save you constantly. Check it. Put 7 back into the original. 7 plus 4 is 11. True. The scale balances. We got it right. Now let us make it one step harder because real equations usually take two moves. Take 2x plus 5 equals 11. That 2x means 2 times our unknown number, and there is also a plus 5 hanging around. We peel these away one layer at a time, like unwrapping something. First deal with the plus 5. Subtract 5 from both sides. On the left, that leaves 2x. On the right, 11 minus 5 is 6. So now we have 2x equals 6. We are close. The last thing stuck to x is that it is being multiplied by 2. The opposite of multiplying by 2 is dividing by 2, so we divide both sides by 2. On the left, 2x divided by 2 is just x. On the right, 6 divided by 2 is 3. So x equals 3. Let us check. 2 times 3 is 6, plus 5 is 11. True again. Notice we did not memorize a formula. We just kept the scale balanced and unwrapped the variable step by step. Quick recap before we add new tools. A variable is a placeholder for a missing number. An equation is a balanced scale. And you solve it by doing the same operation to both sides until the variable is alone. That idea alone carries most of algebra. By the way, if this balance idea is starting to click for you, that is exactly what this channel is built for. So consider subscribing to Simplex Academy. Hard topics, explained from zero, without the fluff. Okay, now let us make you faster. Sometimes an equation has repeated pieces of the same kind, and you can tidy them up first. This is called combining like terms. Suppose you see 2x plus 3x on one side, 2 of something plus 3. More of that same something is 5 of them. So 2x plus 3x is just 5x. You did not need to know what x is to count them. The same way 2 apples plus 3 apples is 5 apples, whether or not you know the price of an apple. The catch is they must be the same kind of thing. 2x and 3x combine because they both carry an x. But a plain number and an x term cannot be merged because they are different types. Same kind combine. Different kind leave them apart. Now, what if the variable shows up on both sides of the scale at once, like 3x plus 2 equals x plus 10? Do not panic because the same rule rescues you. You just gather the x terms onto one side first. Subtract x from both sides. On the right, x minus x disappears, leaving 10. On the left, 3x minus x is 2x, so the equation becomes 2x plus 2 equals 10. From here, it is the familiar unwrapping. Subtract 2 from both sides to get 2x equals 8. Then divide both sides by 2 to get x equals 4. Check it. 3 times 4 plus 2 is 14, and 4 plus 10 is also 14. Both pans match. So even a variable on both sides is nothing new. It is just the both sides rule, used one extra time. Here is a tool for when there are parentheses in the way. The distributive property. It sounds heavy, but the idea is gentle. If you have a number sitting outside a set of parentheses, it multiplies everything inside, one term at a time. So 2 times the quantity x plus 3 means 2 times x plus 2 times 3, which is 2x plus 6. You handed the 2 to each item in the bag. Let us use it. Solve 2 times the quantity x plus 3 equals 14. First, distribute the 2 to get 2x plus 6 equals 14. Subtract 6 from both sides to get 2x equals 8. Divide both sides by 2 to get x equals 4. Check by going back to the very start. 2 times the quantity, 4 plus 3 is 2 times 7, which is 14. True. The distributive property just cleared the parentheses so the scale was easy to work with. A quick word on negative numbers, because they scare people more than they should. A negative number is simply a number below 0, like owing money instead of having it. They follow the same both sides rule. If you have x minus 3 equals 5, you add 3 to both sides and x equals 8. And if solving ever lands you at something like x equals negative 2, that is a perfectly good answer. It just means the missing number sits below 0. Nothing broke. Now let us connect this to real life, because that is where algebra earns its keep. Suppose you are saving for something that costs $60 and you can put away $15 a week. How many weeks until you can buy it? Let the number of weeks be W. $15 per week for W weeks has to reach 60. So 15 times W equals 60. Divide both sides by 15 and W equals 4. 4 weeks. You just translated a real situation into an equation and solved it. That is the actual point of algebra. It turns a question in words into a balanced scale you can solve on purpose instead of guessing. And here is a slightly bigger idea that algebra unlocks. An equation does not only find one missing number, it can describe a relationship between two quantities that change together. Take y equals 2x. This says whatever x is, y is always double it. If x is 1, y is 2. If x is 3, y is 6. It is a rule connecting two moving values, not just a single hidden number. We can even see that relationship as a picture, and this is your first taste of graphs. Imagine two number lines crossed together, one running left to right, one running up and down. That grid is called the coordinate plane. Any pair of values, an x and its matching y, marks a single point on that grid. So for y equals 2x, the pair x is 1 and y is 2 is 1 point. The pair x is 2 and y is 4 is another. The pair x is 3 and y is 6 is another. Plot those points and they line up perfectly straight. That straight line is the same equation, just wearing a visual outfit. Your eyes can read the pattern in the line far faster than your brain can crunch a list of numbers, which is exactly why graphs are so useful. Before we wrap up, let me save you from the mistakes that trip up almost every beginner. First and biggest, changing only one side of the equation. The instant you add, subtract, multiply, or divide on one side and forget the other, the scale tips and the answer is wrong. Same move, both sides, every single time. Second, trying to combine terms that are not alike, like gluing a plain number onto an x term. Keep the kind separate. Third, forgetting to actually check your answer. Plug it back into the original equation. If both sides match, you are safe, and it takes 10 seconds. And here is the one honest limit of our balance scale picture. A real scale cannot hold negative weight, but equations happily use negative numbers. So when negatives show up, trust the both sides rule, not the mental image of physical weights. The analogy got us this far, and now we let it step aside. So let us bring it all home. Algebra is not a pile of random rules. It is one clear idea. When a number is missing, we give it a temporary name called a variable. We write a balanced statement called an equation. And we keep that balance while we unwrap the variable until it stands alone and reveals itself. Combining like terms and the distributive property are just tidying tools. Graphs are just equations you can look at. And the whole thing runs on one honest rule. Do the same thing to both sides. Master that, and algebra stops being a wall of symbols and becomes what it always was. A simple, powerful way to find what you cannot yet see. So tell me down in the comments, what part of algebra confused you the most back in school, and I might rebuild it from zero in a future video. And if this finally made algebra feel less scary, subscribe to Simplex Academy. I am Daniel, thanks for watching, and I will see you in the next one.